Hello everyone, I am Sebastián Rodríguez. I am engineer researcher for Morpho project, and I will present you some of our work in Morpho. So, big spoiler, the numerical simulations are useful for understanding our world and help to predict reality when the treated problems are simple. However, in the most majority of cases, numerical simulations can predict a real system. And in those situations, we are obliged to perform real experiences to verify that our design is correctly done for a given task. The main limitation, however, is that real experience tests are often very expensive to perform, and therefore the design process becomes very expensive. A great solution to this limitation consists in the mix between numerical simulation and experience, that is, an hybrid twin, which is the main subject that we will attack in this presentation. So conceptually, an hybrid twin is very simple. It simply consists in constructing a model that uses at the same time a numerical model using the law of physics that we all know as Newton's laws, etc., and a model built using only real experience data. Here in this presentation, as you can see at the low part of the presentation, we will focus only in one of the principal objectives of the Morpho project, which consists in the implementation of an hybrid twin model applied to the smart manufacturing of composite material aircraft blade by using a resin transfer molding process. Here the model using the law of physics, also called virtual twin, is constructed using the help of nowadays computers. I will not enter in detail here, but the numerical model is based on Darcy's law, which gives the rules of how fluid flow through porous media, and simplified Navier-Stokes equations. This model allows, as shown in this animation, the prediction of injection of the resin inside a given mold. However, as mentioned before, this numerical model, even if using complicated law of physics, it can't predict in several cases the real experience. This because the physics included in the model is not complete. That means that we have neglected some physics in the model. For this reason, we introduce here the hybrid twin applied to the resin transfer molding process, where here we focus in the prediction of the flow front of the resin. Here we consider the fundamental equation of an hybrid twin, as you can see in the slide, where it considers many different terms as the input in order to control a given process and some noise that can be present in the model. Here we focus only in the purely description of a RTM process, a resin transfer molding, which involves only the physics-based model and the ignorance model. Here the ignorance model is built, as I mentioned before, using real data coming from real experience. For those experience, we compare the prediction given by the physics-based model and the one measure of the real process. And for each experience, which are in function of different parameters, we measure and store the difference between the numerical model and the experience, so we can then use that data to construct an ignorance model using regression techniques, as can be, for instance, model order reduction techniques or deep learning techniques. In this slide, we show the final result when constructed an hybrid twin, where here we consider a variable pressure, as you can see in this slide. The hybrid twin here was constructed in order to approximate a more complicated porous media, where different permeabilities are present in the mold. In this situation, we can clearly see that the physics-based model can reproduce the real experience, while the hybrid twin had no problems in predicting the flow front during all the injection process. So finally, here in the last slide, I give you some conclusions of our work in the Morpho project. So we have created a numerical model capable of determining real-time material constant of the process. We have also implemented an hybrid twin applied to the resin transfer molding process, which is capable of giving good accuracy prediction of a real or more complicated process. And we have achieved also an online enrichment of this hybrid twin. And as perspective, we can only say that we have to use this e-routine to perform some control of a real resin transfer molding process in order to optimize it. Thank you very much.